Okay, here we have a question about damping. This is a topic which doesn't come up very much, so nice to see a question on it. As ever, hit pause, then hit play to see my explanation. Okay, so as I say, damping doesn't really come up, and it's one of those ones that I think is a very brief part of the syllabus, one that you will not have spent a lot of time on. It's a shame, it's quite an interesting concept, but it does involve quite a lot of maths, which is probably beyond the spec. Now, what you should be aware is that there are different types of damping. So I've just put them on the screen here. Okay, we've got a combination different damping types here. We've got light damping, we've got heavy damping, and then we've got critical damping. And we've got these statements here. We are interested in light damping. Yep. So let's have a look. We're going to try and rule out some answers. Now, we've got that first statement there, A, which is the amplitude goes to 0 within one period of oscillation. This is one which would refer to critical or heavy damping. Yep. So what you're finding is that when we have critical damping, you'll notice here we very quickly come to a stop, and heavy damping as well. It very quickly comes to a stop within one period of oscillation. And so this light damping you can see here, we still get some oscillations, just not, we just get a reducing in amplitude in this case. Okay. Now, if we take statement C, sorry, let's get rid of the line here, I didn't mean to press that. We've got the another converse statement here, which is energy is transferred from the oscillation as quickly as possible. Again, let's look at our light damping. You're noticing it's still taking some time for that energy to be taken out. We're absolutely removing energy because the amplitude is decreasing. However, it comes quite slowly. This statement here, energy is transferred from the oscillation as quickly as possible, that would be critical damping. Critical damping, we take the energy out as quickly as possible. Okay, and then lastly, we've got this statement at the bottom here. Okay, light damping, yeah, affects the oscillation in all oscillation frequencies. Yeah, oscillation frequencies are always affected by the damping in the system. Okay, so if we have an undamped oscillation frequency, that's the kind of ideal scenario. We'll always have a slight effect. Okay, however, what we notice here is that the oscillation frequency is consistent over time. And you can see this drawn here. I've got a consistent time period, i.e. a consistent frequency, which is why the answer here is